Thank you. Yes.
Yeah. So now I ask Mr. Osama to start your presentation. Is it okay, Dr. Ismail? I asked him.
Yes, yes.
Yeah, please, Osama, start your presentation.
Okay, thank you. Good evening, everyone. Thank you for joining me here today. I am Osama Hindi, and I'll be talking to you about my special project. Well, it's called the special functions, so it is special. But why these functions are special? Well, on the first day at the university and the first lecture of Math 001, we studied the functions, which is an action to map something into another, whether it is linear function like x plus 1 or quadratic function like x squared, etc. And other functions like trigonometric functions, exponential, logarithmic functions. We studied all of these functions with simple mathematical operations. So then we learned the differentiation, which is to calculate the ratio of rate of change between two variables. And also we learned the integration to calculate the area between curves or the volume of a sphere, etc. It has many applications. So my point is all of these are only tools, and the special function contains many tools. It is like a machine. So to know more about these functions, let's move on to the next slide. Okay, here is some questions, but before this, I have one question. Says how these special functions evolved. Well, whenever we try to solve some real-life problem, it would be formulated in terms of partial differential equations. And we usually transform this partial differential equations to an ordinary differential equations and try to solve it by the analytical methods. But we are not lucky always to get a nice solution. So we must look for the method of series solutions. And that's how these new functions came, so-called special functions. Okay, now the second question, let me use a pointer. Okay, here the second question, what are special functions? Well, we have many special functions like gamma and beta functions and Legendre polynomials and functions and Chebyshev, Bessel, Legendre, Hermite. They all have special functions. There are so many. So the next question, why they are special? Well, they have many properties and applications. So what are these applications? The last question. Well, the most common application in special functions is the approximation theory, which we will use in our project later on. And other applications, like for example, in Legendre differential equation, it appears when we solve the Schrödinger equation in 3 dimensions. Also in Laplace equation. Okay, let's start with the first special function here. Here we have Legendre polynomials and functions. Well, at first I thought we can solve this differential equation by Laplace or Fourier transform, but obviously the only solution is by the method of Frobenius, which gives a series solutions. So after solving this differential equation, we got this solution, the first kind, and from this solution, Legendre polynomial, we obtained the second kind by setting y, let me write, by setting y, okay, it's difficult to write, z equal to times this solution, polynomial, Legendre polynomial, and finding the first derivative and second derivative and substituting here in this Legendre differential equation. That's how we obtain the second kind. So let's see the plots of these polynomial and function in the next slide. Here is the plots of Legendre polynomials bounded from -1 to 1. This is P0, P1 until P5, taking a nice shape. Okay, this is plots of Legendre polynomial, the first kind, and this is the second kind. So now we have the most important property, orthogonality property of Legendre. But first, let's define this property and see the difference between the orthogonality property in vectors and in functions. Well, it has the same word, but they don't have the same meaning or the same definition. So in vectors, we say two vectors are orthogonal to each other if the inner product is 0. Then we say they are perpendicular to each other. But in functions, it is different. Two functions are orthogonal if the inner product is 0, which is when we multiply two functions and integrate it from a to b, then it is equal to 0. But we don't say they are perpendicular because there's no geometric significance to be orthogonal to each other. So let's go back here. The orthogonal property of Legendre, it is integrated from -1 to 1. This is one Legendre polynomial of order L, and this is another polynomial of order M. If the order are not equal, then it is 0. This is the orthogonality. And if L, the order are the same, then it is 2 by 2L plus 1. So we finished this property in Legendre. Now we have Bessel functions. The same thing here. You can see here the Bessel differential equation, x squared, the second derivative of y, x, the first derivative, x squared minus v squared y equals 0. This differential equation is very similar to the Cauchy-Euler that I have learned in differential equation. But if this term doesn't exist, then it is Cauchy-Euler equation. But this is Bessel differential equation. So we use here the method of Frobenius to get a series solution. So after solving this differential equation and finding the series solution, we got this Bessel function of first kind. I have written everything in detail in my project, how we obtained this Bessel function from this differential equation. So here we have the second kind obtained with the Bessel function with the negative values. So let's see the plots of these solutions. This is the plots of Bessel functions of the first kind. It's a really nice shape. Yeah. So This is the second kind of Bessel functions. So let's see the orthogonality. Now, this is the orthogonality property of Bessel. It is integrated from 0 to 1. This is multiplied. This is one Bessel function multiplied by another, where a and b are the roots of Bessel functions. If a not equal b, it is 0, and if they are equal, it is half times the square root of Bessel function of order v plus 1. Okay, now let's move on to Chebyshev. Should I discuss about Chebyshev, or I move on to applications?
No, little you discuss. Tell us a little bit. Yes.
Okay. Now Chebyshev polynomials, the same thing here. This is the Chebyshev differential equation. 1 minus x squared, the second derivative, minus x, the first derivative of y, plus n. This is of order n. This differential equation of order n equal to 0. So we use the same thing here, Frobenius method, to get a series solution. So I wrote here the second kind, and here's first kind because it is longer. So this is the first kind that we obtained, Chebyshev polynomial of first kind. And this is the second kind. So let's see the plots. This is the plots of Chebyshev polynomials, the first kind. And here's the second kind. Here the orthogonality property of Chebyshev. This comes from the cosine function. The cosine function orthogonality, integrating from 0 to pi, cosine n theta times cosine m theta d theta. It is 0 if n not equal m, and the same thing here, pi by 2 if not equal 0, pi if equal 0. Okay, now the application. Approximation of functions. So with the Legendre polynomials, we can represent a function as a linear combination of coefficients together with polynomials and approximate functions. Any function, but some functions may have an error in the approximation. So we try to minimize the error and try to get a nice result. So by Legendre series representation, f of x equal to the summation of the coefficient of order L times the Legendre polynomial of the same order from 0 to infinity. And this the coefficients we can obtain from this integral. So the same thing with Chebyshev. The only difference here, the coefficient of order 0, here 1 by pi, sensed from the cosine function orthogonality, 1 by pi. And n from 1 to infinity, it is 2 by pi. Let's take an example. Okay, here is an example. F of x equal to x squared. When we try to approximate this function, we get a naught, the first coefficient, 1 by 3, multiplied by the same order of Legendre polynomial, p naught, plus 2 by 3, p2. This is the of order 2. Here the odd orders are vanished. maybe the integral of odd function from -1 to 1 becomes 0. That's why they are vanished here. This is for Legendre, this is for Chebyshev. T not T2. Okay. That's all I have.
So, experts, please ask him some questions. Dr. Ismail, please ask him.
Yes. How can you obtain the initial equation? Osama, you learned me?
Osama, could you hear him? Osama, are you online or you have become offline?
Oh, my mic was switched off. I don't know why. Sorry.
Okay. So Dr. Ismail is asking how you
Yeah,
can get initial
Yeah.
equation.
Yes. From the Frobenius method, we take z equal to the summation of an times x n plus s. Then we find the first derivative and the second derivative and substitute in the differential equation for Legendre or Bessel or Chebyshev. So then we take x of x power 0, the roots, and take the coefficients of x s plus n. Then we find a naught, taking n equals 0. Then we will get the initial equation. I have written in details in my project. Should I explore my project?
No, it's okay. It's okay. Dr. Ismail, are you satisfied with his answer?
Thank you, Osama. I don't have any more questions, but you must write E naught don't equal 0.
Yes, yes.
You have to assume that E naught must be not equal 0.
With the initial equation, we take a of 0.
You got a formula like E naught times some E naught times some terms of S equals 0.
Yes.
So you have to put the condition that E naught must be not equal to 0, or that will be the initial equation.
Correct.
Okay, it is very good work. It is excellent work, Professor Kalimuddin, and Osama is an excellent student.
Yeah, he is a good student. He has done nicely.
Thank you very much.
Dr. Said.
So, Dr. Mudassir, please.
Yes, brother, you have done a very good work, and I have gone through your project. And you are lucky that you have worked with Professor Kalimuddin, who is one of the renowned professor in India. So, before asking the question, I would like to give you a suggestion that you have done very good work. So please extend your work and try to publish this work in reputed journal. This is my suggestion.
Thank you very much. Inshallah, I will try.
You are working with very renowned professor, and he is really renowned professor in India. So you are fortunate.
Yes.
You are praising me.
No, not. We are really. You are really lucky enough that you have worked with Professor Kalimuddin.
Yes, alhamdulillah. Yes.
Now I want to ask two questions. You have shown the graph, but you have not explained what finding you have got from the graph. You have shown, you have plotted various graphs, but you have not explained what finding you have got from each graph. So have you studied about that, or just you
Yes,
have plotted the graph only?
each plot, for example, P naught equal to 1, that's why it is plotted in 1.
Yes, you have got the various graph. There must be some findings from each graph. So we should analyze that. The second question is, in the orthogonal properties, you have considered the range in between -1 to +1, and in some orthogonal property, you have considered between 0 to 1. What is the reason behind that?
Yes, I have wondered.
What, brother?
I have wondered of this question, but I didn't really have the answer. So I thought
Can
in
you come back to your plot? Can you
okay.
come back to your plot of Legendre?
Yes.
Yeah, Dr. Madhuri is asking that you are integrating it from here from -1 to 1. Okay.
Yes.
So why it is so? When you are trying to
Yes.
solve by Frobenius method, have you thought about convergence of this?
Yeah. Frobenius method assures that it is convergence between -1 to 1, but the boundary he's not sure. So because we use the Frobenius method, that's why.
Yes, because if you don't consider convergence of solution, then it all become useless.
Yeah.
Okay, so
Yes.
you have to take into account the convergence of. And similarly here, you just go to the graph of Chebyshev.
Okay.
Chebyshev. Again here it is -1 to 1. And what about Bessel?
Bessel?
0 to 1.
Yeah, Bessel it is 0 to 1. You see? Bessel's function. You are taking here from, it is from, do you have any other plot? Second one, just show me. Yeah. Second plot of, yeah, second kind, okay. A Bessel's function. So it is from 0 to, well, so it all has to with the convergence.
Yes.
So you should go through once more this Frobenius method. So everything is mentioned there in book. Okay.
Yes. Okay.
So to say,
That's it from my side, sir. Thank you
okay,
very
that's good. I'm happy that experts they ask pertinent questions, and that would help him to improve further. And I suppose that these expression functions can be used. I mean, as a wavelet. Okay, so I can give you some work you can do in this vacation. Okay,
Very good.
so when the university opens, maybe you will be having some more ideas so that we can extend this work and send it for publication. So I wish you all the best. So Dr. Ismail, thank you very much. Dr. Mudassir, thank you very much.
Thank you, sir. Thank
You
you.
are welcome.
We'll
Thank you.
connect the other session.
Yeah, so we connect another session. Okay, Osama, all the best.
Okay. Thank you. مع السلامة.
شكرا جزيلا أسامة، بالتوفيق إن شاء الله. مشروعك كان جميل يعني.
آمين.